if big T of t is 58 times e raised to the negative 0.044t plus 72, what happens to t and to t prime as little t increases? Well, let's see, okay? I'm going to do, because you see this is two parts, right? I'm going to talk about the big T first. What happens to big T, not big T prime, okay? So I'll do this by, because look, when they say T increases, I'm going to say little T is going to increase. Like how big? Like 1,000, million? Oh no, infinity. I'm going to just make it go to infinity, okay? So let's find the limit as little t increases to or approaches positive infinity of our original function, okay, which is 58 e raised to the negative 0.044t plus 72. Right. Haven't done limit in a while, but hey, that's okay. We can do this. Well, for this one, I'm going to rewrite that first exponential term, okay? Look at this. I'll underline or I'll highlight this. That is an exponential term with a negative exponent, right? So I'm going to rewrite it so that we have 58 on top of the fraction. And that term with the negative exponent, I'm going to send it to the bottom of the fraction, but change that exponent to positive this time, okay? Nothing is changing to this plus 72, just still there. All right, now let us think about this, okay? What will happen if you plug in infinity as t value here? Imagine plugging in a number really, really big to this denominator, okay? Something like this. 58 divided by a really big number, like, well, it's not that big, but I'll say million, okay? And infinity is even bigger than that. Like e raised to a millionth power, it's gonna be just a really big number, right? So think about dividing $58 to millions of or billions of like thousands and zillions of people, okay? Each of them will get like what, how much? Nothing, right? So what I'm trying to say is when the denominator is getting super big and the numerator is just a number, we're dividing a number by an extremely big number. So imagine like if I divide 58 by like even like 10,000, you see it's getting really close to zero, right? And if I type in 100,000, this is so small they start using a scientific notation, right? So I just wanted to show you as the exponent, I'm sorry, not the exponent, as the denominator, this orange part gets super big, the whole fraction is approaching zero, okay? So what I'm going to say over here is this is equal to 0 for this fraction, because that's what will happen if you plug in an infinitely big number to this t. But the 72 will not be affected by it at all, right? So what's the limit? Just 72, okay? So what I can say is as little t increases, a big T approaches that horizontal asymptote of 72. So that will be my conclusion. And I may be able to like make a note over here that I know that limit as t approaches infinity of 58 divided by e raised to the 0.044t equals 0. I'll make a little note like this. Note. Okay, and using that note, We got the limit of that original big T to be approaching 72. Now we can confirm this by graphing it real quick. Let me see. Desmos graphing calculator this time. And I'll graph this original function they gave us. 58e to the negative 0.044. I mean, they don't do t, so just use the letter x for me. And then 72. Now I'm going to have to zoom out because we have a big horizontal asymptote of 72. You see, here's the graph of that function we were just working with. And I'm going to graph y equals 72 and use a dotted line right there. And I'll show you that what we got is correct. Now look, as x or t approaches, as the input value approaches, we're talking about how we approach the right end of this graph, okay? As we approach the right side of this graph, you see how the graph is approaching that blue dotted line, right? I mean, I'm gonna have to zoom in closely, but it never really touches this blue dotted line. It just gets infinitely close to it. And that value that we are approaching is, as you can see, I want to be on the red line, not the blue line. That number that we're approaching is 72. So we're getting infinitely close to 72. But if I zoom out, you'll be able to see that we never really close that blue line to go below it. We just get super close to it. Okay, that's the horizontal asymptote. Now they want us to find what t prime is approaching as little t increases. Well, in order to do that, we do need to find what t prime is. So what I'm going to do is I'm going to copy this to another page and do the limit. Well, do the derivative first, because now we need to find t prime of t. T prime of t is going to be, well, the first term is an exponential term with base e. So to find the derivative, you multiply 58 times negative 0.044. Right, I'll do that on my cell phone calculator. Give me 1 second. 58 times negative 0.044. What did you get? I got negative 2.552. And the exponential term stays the same. E raised to the negative 0.044 t. And the derivative of 72 is 0, right? We can put plus 0, but we'll know that doesn't really change anything, so we can just erase it. Now, what we are doing to answer the question being asked is finding the limit as little t approaches infinity of that t prime of t. So let's write that down. What's the limit as little t approaches infinity of negative 2.552 times e raised to the negative 0.044 t. All right, what I'm going to do is I'm going to rewrite this as a fraction form, okay? So I'll copy this down the same. But what I'm noticing is that this term has a negative exponent, which means I can send it to the bottom. So I have negative 2.552 on top of the fraction. But in the denominator, I will have e raised to the positive 0.044 t. Now we're raising an exponential, or like e, to like let's say infinitely big power again, right? So you see the denominator will be a very big number. So what we're doing is we're dividing negative 2.552 by a really big number. So let me try that, okay? So over here, let's try. What will happen if you do negative 2.552 divided by a really big number? See what it is approaching? It's approaching 0. Well, from the negative side, but it's really getting close to 0, right? So the limit of this fraction is equal to 0. Okay, this is equal to 0. So here's my conclusion, answering the question that was being asked. As little t increases, t prime approaches 0. And I've shown the work y, right? But let us check and see if this is correct, okay? We can graph the, not the original function, but that derivative function, negative 2.552 e raised to the negative 0.44. Instead of t, I'm going to plug in x because that's what Desmos used to graph. And my answer was that this function will have a horizontal asymptote at 0. And take a look. As t approaches infinity, or as x approaches infinity, they're talking about going to the right side. What is this red graph approaching as it's going to the right end of this graph? You see it's getting closer and closer to this blue dotted line, which is at y equals 0, right? So we were right about this conclusion. Okay, assuming this is the right derivative and we got the right derivative. So that's how you can answer this question. And this one was question 11 on exam 2 practice problems.